Hey everyone, welcome to part 6 of my TRS-80 Model 16B restoration video. In today's video, we're going to take a look at the floppy drive controller calibrations that are available to us. This machine, and looking through the service manual, some pages from which I've printed out here for my reference, the only adjustable component on this is the floppy controller. And it gives a nice procedure in the service manual here for test points to connect to and what needs to be adjusted in order to do this. It even gives you a nice little diagram of component locations. And so I'm going to go through this procedure. The main things to keep in mind are there's 3 test points. You can see I've got my scope probes on already. And I could have just done one channel at a time, but I don't trust myself to poke metal things in there while the machine's running. I'm a little bull in China shop sometimes with things like this, so I figured just setting up all 3 probes was easier. You have to put it in a floppy controller test mode here, and this jumper goes from the storage position of E31 to 49 over to E30 to 30. The instructions take great care to mention that for one of these adjustments, the machine has to be on and measured either within the first 60 seconds or it has to wait at least 8 minutes. And you'll get different answers if you don't. So I think what we're going to try and do is see if I can get that one measured up quickly. That's going to be channel 1, I believe, is TP9, right? Did I do that? I did. Okay. And one other note, when you unplug this, or when you take the card cage off, you have to take off the grounding wire. Make sure you put it back on. I happened to catch it as I was getting ready to plug the machine in, otherwise I wouldn't have had a ground reference, and that would be dangerous for me too, because the machine wouldn't be grounded. So, if the frequencies all come out right, or if I can't get them right, one of the things we will possibly do is take a look at this floppy controller. This is a WD2793. So I'm going to lock the camera down and we're going to power this up and follow the procedure. Alright, so per the instructions, I got the scope here ready to go. I'm going to power this on, hit the reset button, and then I'm going to throw the jumper into E30 to 31 and we're going to see what happens. So on we go. I'm going to hit the reset button. And then I'm going to try and shove this into the correct position. Okay, and see if the scope will find it. We have a signal. Okay. And right now we're measuring 271 kilohertz, which is still too high. But now the issue here is it says that I've got to be within 60 seconds of powering the machine on. I'll wait the 8 minutes. We'll wait 8 minutes, let this thing kind of cook, and then I'll come back and we'll adjust it to 255 kilohertz. Alright, I've moved the camera over closer to the screen. Hopefully you can see it and my fat hairy arm doesn't get in the way. Alright, so it's been 78 minutes, so while I'm letting that last minute elapse, we're going to talk about what we're doing here. This is the TP9 one, that's channel 1 on the scope. And we have it watching the frequency, which currently is sitting around 263 megahertz. And with a power up time of at least 8 minutes, it should be, nice if I said megahertz, I meant kilohertz. It should be 255 kilohertz. So what we're going to do is we're going to adjust C61, which is right there. I'm going to try to do this as carefully as possible without hurting myself. And we'll see what we get, and without damaging the machine. Ooh, there we go. I think I got it, 255. Excellent. Alright. That took a little bit of fidgeting, but I did get it. So, we're not going to touch that one anymore. Don't know how the hell I pulled that trick off, but there we go. Alright, so the next item up for bids here is TP10, which is channel 2 on the scope. Now I'm going to turn off that, and we're going to hit the button here. See if it'll find it. It did. Okay, perfect. And now what we're looking for here is a positive pulse width of 200 nanoseconds. Get my measure button back here. Okay, there we go. I'll measure it off. Let's just see what we have here. Oh, there we are. Okay, so, oh, okay, that's sampling channel 1. That's why I'm not getting the stat update. Okay, so I'm actually pretty close. So, looking here at the pulse width, I'm right around 200 nanoseconds, actually. Dancing right around it. That's pretty good. It's dancing around enough I don't think I'm going to get much around there. And I seem to use, on average, 10 below, 10 above, but hanging right around 200. I'm going to call that good. Alright, so let's do this. Let's turn off the measurements and the stats for now. Let's turn off channel 2 and turn on channel 3. Okay, and let's just hit the button here so that this does a nice job of determining my trigger levels and such. Okay, so this one says it needs to be, this is TP9, adjust R51 to the right of R50 where I was just poking my screwdriver, to 500 nanoseconds. Alright, just give me my stats back. Ooh, we're close. 500. Okay. I don't think I mess with it. Same kind of thing, I'm fluctuating with 10 plus or minus. So, that one I don't think I have to touch. But, for C61 was quite a ways off, so actually, let's turn off that and bring you back. And when I look back to C61, that's channel 1, we're right around 254 kilohertz. And there's no way I'm going to get a granularity of 1 out of that thing. So we're going to leave that, and then we're going to go over to channel 2, and we're going to see what we're looking at there. Button again, I'll hit the measurements, take the screwdriver out of my hand lest I poke something. Okay, and measure on, and we're right around 200, 190, 200. Okay, so I'm hoping that since these did actually need adjustments, that the timing was off, and now will be correct. And what we're going to do to find this out, we'll disconnect the scope, I'll get the cover up here, and we'll throw the card cage back in, and I will boot the floppy emulator up, and we'll see what happens. Of course, before I do that, I've got to put this jumper back in the original position. But that's that. I'm actually pretty happy with the adjustment, and I'm new to this scope, as it's probably pretty obvious. I'm watching me operate it, but it's pretty easy to navigate and work around, and it's pretty cool. Okay, so we're partially assembled. I'm going to power this up. I've got TRSDOS disk mounted, jumper back in the normal position, and the card cage just has 2 screws in it. One, well, I didn't completely destroy the thing because it booted. One for the ground screw on the AC power side, and then the other that has the blade for the CRT grounding. So let's just give this... Okay, we still have the error, so let's see what we do. Okay, we're going to try one more thing here, but it looks like the floppy timings were not the cause of my problem. Alright, in lieu of our failed test, it's no worse, but it's no better, I've removed the floppy controller chip, the WD-2793, from the slot. And what I'm going to do actually is just run a little Deoxit into the slot and exercise the part around a little bit. Just make sure that there's nothing really funky going on in there. It doesn't look like it's in too bad a shape, but I think what I'm going to do is brush on the Deoxit with a swab just so I don't spray this crap all over the motherboard, because it tends to be messy and not really come up. So we're going to do that. I may also loosen and reseat some of the other socketed chips here just for the sake of my own edification, but we'll see how far I get with that. But I want to start with the floppy controller chip. And worst case, I might see if I can find another one of these. Now this is going to be a bit of a thing because a lot of times the ones you'll find on eBay or elsewhere are cheap knockoffs and just junk. So I'll have to see if I can source one. I got to poke around too. I might actually have a couple controllers floating around here that have the chips in them. So we're going to do the Deoxit on this, and then I'll probably slide it back in and give it the couple minutes that it needs to dissolve, and then we'll try and power it back up again and see what happens. It's a little off-label, but the label does warn you against spraying this directly on delicate things. I don't know. I guess in that sense all electronics are delicate, but alright, just gotta be careful. Just kind of rocking the chip around. Not too much. I want to be careful not to bend any pins or anything, but I also want to be careful to make sure I kind of exercise the socket here. It's kind of in and out. Okay, I think that works. I don't know if you could see that, but basically just kind of get the pins initially lined up, and you can kind of rock back and forth slightly without bending the pins. And do that. We're going to apply a second little thing because the hand tells you to apply some more. This now needs to wait. I actually am going to grab my excellent holders here. Let's break out my high-tech grabbing apparatus. This will hold my cables up. I want these to dry. If anyone is watching, U54 here, which I wonder if I can get more on the camera. Hey, I can. I don't know if this is a factory label or not. I have no idea. I was kind of surprised to see it. And I don't remember in looking in the Model 12, maybe the footage I have when I did the card cage video will show, I don't remember it having that kind of label on it. So I don't know if that's factory or not. If it is, or if it isn't, if you know, let me know. I would be curious to know whether or not that's actually factory. Alrighty, let me just, just kind of sop this up and watch where I stick my hands here. I have this grounded. I don't know if you can see, I always reconnect the ground lead here, and the machine is plugged in. And I'm doing that so this way I don't build up any static electricity, cause any problems for myself. Some dust, but nothing major. Alright, so we're going to let this sit another minute or two, and then we'll throw the controller chip back in, and we'll see if we get anything out of it. I don't suspect this will do anything. Alrighty, I think we're ready to reassemble this now. Touch ground. Alright, and I'm just going to line this back up, notch over to the left. This socket, by the way, is U46, for those of you wondering. Okay, let me just make sure I lined up the holes here. It looks nice and clean. And they're lined up. A little push. Okay, it's in. Okay, and I'm going to reconnect the power here. Make sure that runs back where it should. These are going to come off. That's correct. Okay. Make sure that's under there so it doesn't get all... There we go. Bind that up on the thing there. Okay. I'm going to pull this screw back off. We're going to get the card cage back in here, and that's going to be it. And by that I mean I know it's going to do it. So, 1, 4, yeah, I don't care about the time. Okay, well, that doesn't mean much, it's kind of random. See, there you go, that ain't right. Yeah. Yep, okay. So we're where we were. So I'm going to have to start doing a little more diagnosis. I might do a little reseat on the other chips on the back there, just for the sake of my own edification. Alright, so given the problems we had before, it's time to do some resocketing. I was hoping to avoid this, but when you have problems and machines this old, might not be a bad idea to just pull these apart. So what I've been doing is just kind of doing some cleaning up, and while doing that, I accidentally discovered this. I was asking about U54 earlier in the video, and it turns out, I was like, that doesn't look like a stock part. Yeah, it's because it's not. It's an EPROM. So I'm going to have to pull this out. This is a 2716. I'm going to get a piece of foil tape and put it over this just because I don't want to run the risk of it getting destroyed, the contents on it getting damaged. So I'm going to get my foil tape out, cover it. I'm going to take a reading of it with the EPROM reader, and after we take that dump, I will see if I can get a hold of a 16B ROM image and compare it, because I thought that looked kind of funny, but it was blocking. What was interesting was I noticed it was an SGS part, but the way it was sitting, it was blocking the part number. So if I had seen 2716, I'd have known that was an EPROM, but it was kind of blocking it, so I didn't really see it. At least it was blocking it enough that I didn't notice it. So that's a neat little discovery. I wonder what's different about the ROM in this versus the ROM in the other machines, or if there is anything different. But so if the ROM is different, I'm going to throw the stock ROM back in just to see if it changes any behavior. But I'm also super curious about what this is. So neato. Alright, so we're going to cover this with foil tape, and I'm going to extract it, and then I'm going to do all the other chips here and just kind of lift them out and put them back in. I might actually shoot them with a little bit of Deoxit. I'm gonna get the can the right way. There we go. Deoxit. Fan of white I am. And yeah, we'll go from there. If that doesn't work, I will have to start digging around on the signal lines. I still suspect this 2793, but I don't just want to go swapping parts yet. So I do have spare CTC and PIO chips if I suspect those. So far, the rest of the machine's working well enough, and I haven't had any weird problems that I'm going to touch those just yet. I don't have any Z80 DMA chips yet, so you know, we'll just kind of play. That's the DMA, dumbass. That's the SIO. So, all right, enough jabbering. Let's get this covered up, and then we'll do some socketing, shall we? All right, HVAC foil tape here. I like this stuff. It does a nice job blocking everything. It also comes off fairly easily if you want to reprogram it. So the only thing you have to be careful about is not bridging pins with it, because it's foil. But it does a nice job of keeping things nice and covered. I really like it. So let's just get that on there. And I'm going to just snip off that corner there, because I feel like I may have... Oh, maybe not. I just want to get that little corner off there. There we go. It was too close to the pins for my liking, so I got that off. Alright, so that is good. No touching the pins. This is now covered in a way that's not going to be a problem. And this is the U54 sticker, and interestingly enough, on the board, of course, it says U54. So I imagine someone had this in a collection, took it out, put it in, and that is now why I have it. So, hey, I got a free EPROM. Okay, back to socketing. Time to get doing this. It's another day, and I actually posed my question on the Tandy Discord and got some great info and a reminder that I'm a moron. I didn't do what it should have been step 1 or 2 of this when I got the machine apart, and that's checking power supply voltages and things like that. And so that is going to be added. I'm going to finish reseating all these chips and cleaning them with Deoxit and everything like that, including the RAM. So that's going to be my next little bit. And then once I'm done there, when we're done with that, I found out that these machines, also from the Discord, that these machines actually came with EPROMs. So I just assumed that this was different because most of my Tandy machines just have regular ROMs in them. So not EPROMs or anything like that. So I'm going to take this out. There is an upgraded recommended ROM version that they were nice enough to share with me. So we're going to take a dump of whatever's in this ROM, and then I'm going to flash it with the updated boot ROM. It shouldn't make any difference in my floppy issues, but it is recommended, so we're going to do that. And in the meantime, if you hear a little background noise, we're watching Coco Talk. So we're rocking the 8-bit world while also trying to fix the 8/16-bit world. Fun times. Okay, so let's get this show on the road. Back to the speed up of the chip resocketing and socket cleaning, and then on to the ROM. Alright, last but not least, U54. This one's last because I need to pull the image off it. Even though this does match the checksum of the other ones, I want a copy of this ROM for posterity. So I'm going to do that, and then I'm going to flash on the FDIV version of the boot ROM, run the second Deoxit pass on this, and then we're going to let it sit for a couple of minutes and make sure all this dries up. It says you can turn it on after 2 minutes, but I'm just going to wait. But everything else has been redone. And I think we're ready to do that. Once we're done reprogramming it, I will put this in, we'll put it back together enough to test it out, and then we're going to put the full complement of cards in it and move on to checking the power supply. Time to dump the EPROM and then update it. If you're wondering, I'm in a weird spot today, and the reason for that is this has kind of taken over my room. So this is a view of the computer room as it stands right now. That wonderful set of Tandy computers and an Apple II there. There's the complement of 16B pieces, and my drawer of programmers and junk, and the rest of it. Don't know what made me think to show this, except for the fact that because I have all this stuff around, I'm kind of in a crunch for space. So, but it's not because I have too many retro computers. No, definitely not at all. All right, so we're gonna pick the device here. This is an SGS M2716, if I can get it into the frame there. Oh, that's right. 2. And so we're going to go down to SGS, and there's only one. Excellent. Apply external power. External power is applied, so this should work. And we're going to read this. Okay, let's clear the buffer. Yeah, let's just fill it with FF, and let's read. Read completed. All right, let's go to the buffer. I'm just going to scroll through it. Oh, there we go. Boot error, insert diskette, diag. Excellent. Okay, see the text in there. End boot. Interesting. End boot. So it looks like a comment. Huh. Neat. Okay. I didn't expect to see that. Alright, we're going to save this. Alrighty, so I've downloaded the ROM. Let's take a quick look at the README here. Okay, Frank Durda added support for the Model 2000 keyboard and the Hitachi 64-180, along with a host of other fixes and optimizations. Has a checksum of DF85 in the reader and 8085 in M2. And it's been run in the 16A, B6000 TRS-80 GP. When the ZX 3.3 upgrade was released, I started using the 2000 keyboard. Boot ROM tar contains the source code and binaries for several ROMs that can be built using ALDS. Cool. This is very cool. Alright, so aside from the fixes, the biggest thing it adds is the extra support. So this will be good to have. So what we have to do now is I need to break out the EPROM eraser, and we're going to erase this ROM, and we'll come back. Alright, say hello to my crappy EPROM eraser. It works, it just, the timer's bullshit. It doesn't actually do anything, and I just kind of have it hacked so it stays on. Just the knob quit working, so I jammed it. But it does work. It just, this is not a device I would trust to leave unattended. I feel like it's the kind of thing that will set my house on fire. Okay, so it is 146. We'll come back at 156, and that should be erased. We'll cover it with tape again, and we will program it and try it out. Okay, time to cover this and program it. I know some folks don't cover these. Maybe it's just because I don't keep them set long enough. Alright, here we go. Okay, window covered. You can see the part information. SGS M2716. Back into the programmer you go. Alright, and we're going to go back to here, and we're going to fill the buffer with FF again, and then we're going to open, and this is FDIV 89. Okay, and I'll just, well, there we are. Boot, insert diskette, boot error. There's Frank's initials, FDIV. And he's padded the rest. Okay, so let's give this a write. Okay, I think that was okay. We're going to go to the log and make sure. Device write okay. Verifying buffer. Device is verified. Excellent. Let's do the last pass of Deoxit on the socket, and we're going to put this in and power it up. Alright, last pass of the Deoxit. Okay. Lined up. Excellent. We're back in. This is going to sit for a couple of minutes. It says to wait at least 2 minutes. I'm probably going to wait 5 or 6. And while that is actually happening, that'll give me time to put it back together. Time now 14:02, so by the time I get this back together, we should be close enough that I can kind of do this. And before I put this together, I almost forgot. I'm going to shoot some Deoxit into the connectors here. I really don't want to do that over the machine, so let's move my tools and we'll do this over the table. Alright, got this plugged back in. We're going to route this, actually plug it into the floppy drive because it'll actually make it easier. Now I have to be careful again. The switch is live there, and the reason is I left it plugged in so that I could ground myself constantly, so I'm not introducing any static to these machines. It doesn't have time for that static. Alright, we're back. Power applied, not on, but so I can ground myself. Before we put this together, I'm going to do one more thing. We're going to throw some Deoxit into the connector here, and on the card edge of the card cage, and we're going to go through each of these. And then when I do put the Type 2 interface and the video card back into here, and the other cards actually, I'll just quickly go over the card edges of them, just so I don't, if I clean these and put dirty cards in, I'm just going to pollute it. So. Alright, here's a configuration you don't see a 16B in much. This is the video card right in the mainboard slot, as you would find on the Model 12. And the reason I'm doing this is twofold. First, I've done all the Deoxit on the card cage, on the cards, on that slot, everywhere, and the socketed chips that I did. So what I want to do now is just power the thing up and make sure that it is functional, that it boots. And this is also a test of the, make sure I burned the Frank ROM correctly. I did. So that's a plus. Again, 1, 8. Alright, I just said it and I forgot it already. 11. Don't care about the time here. Okay. Sometimes it doesn't throw an error there, so DIR. That's not good. Ha! Yep, okay. Basic will blow up too. Okay, so, not that I expected that to fix or change anything. Load file format error, error 22H. Alright, so LSDOS is still LSDOS. But, the machine is behaving exactly as it did before, which means I didn't break it. So, that's good. Now what we're going to do is we're going to load the card cage in, get that in, screwed down, and all of the cards are going to get populated. And then what we'll do is we'll power it up again, and we'll start checking the various voltages and see what we've got. Alright, all reassembled, card cage in, cards in. This is the first time since I've had the 16B that all the cards have been in it. I did a quick once over on the 68,000 cards because I hadn't looked at those before in the serial port board. I just kind of made sure they were clean, made sure that I didn't have any bent test tips or anything shorting out, and that the memory address space on the 68,000 boards was configured so that they weren't conflicting. And I'll go over that when I go over the 68,000 boards and we add them to use them. We're not going to use any 68,000 functionality today. The reason they're there is all the boards have to be in. For the power supply test to be accurate, I need to put this system together and operate it as it's going to be run day to day. If I don't put all the cards in, the voltages line up, things might not line up when all the cards are out. So that's why everything is now in. So there is a particular order to these cards. You have to do this right. So that order is as follows. All right, so you can see here, this is from the technical notes and jumpers. I printed this couple of pages out for reference. The order is ArcNet board, which I don't have. That would be really cool. The hard disk interface board, the multi-terminal board, the video board, any Z80 memory boards, which I don't have, and then the 68,000 and 68,000 memory boards. So you'll see that I have that order for my cards from bottom to top. Hard disk, serial, video, then there's a gap, and then the 68,000 boards. This ordering matters. You have to put them in the right order, otherwise the Z80 interrupt system won't work properly. The 68,000 boards do not use the Z80 interrupt system, so they can be in any order. Well, I mean, they have to be in a specific order. This is the CPU card, and these are the memory cards, just for the cable to line up, but they don't have to be in any order related to the Z80 boards, is really how I mean to say that. And there can be a gap in the slots, since they don't use the interrupt system. So, let's power this up. I'm going to boot TRSDOS 4.2 and make sure that that boots, and I might run a couple of the diagnostics real quick, and then we're going to get to running the power supply checks. Ready to go? I've got TRSDOS 4.2.5 mounted, and we're going to boot this up, and hopefully everything comes up. Good sound. Okay, at least the TRSDOS basic diagnostics pass. When this boots up, I'm going to run the full TRSDOS memory test. Takes about 8 minutes. That'll give the system some time to kind of get going and stable. And I am going to run a couple of the other diagnostics in TRSDOS, the diagnostic diskette. That way I can make sure that at least the system is in about the same state that I had before. Mainly I'm focused on the memory and system tests. So, today is oh, I love the click, 2022, and I apparently can't type. And the time now is 15:41. And I know I could just disconnect the stupid clicker, but I don't really want to disable a feature of the machine. Plus it's got its own little appeal. And other operating systems and programs don't make quite such an obnoxious beep. Alright, we want the full test. Okay, we'll be back after these messages. Basic memory test is successful. Let's move over to TRSDOS Diagdisk, and I just want to run some of the other memory tests over there and make sure that the system is up and running. I will say, if the power supply voltages check out, I think what I'm going to do next is we're going to boot the XENIX 1.3 install disk, because you can get a shell with it. And if I can get a shell and the floppy drive is reliable enough to read, I might table this, because the whole idea with the system is it's going to be a XENIX box anyway down the road, so I don't know that I want to waste time trying to get LSDOS working. But I have to keep this in mind, so, or if it does cause other problems, I don't want to forget this. So I have to remember it. Okay, the screen looks good there. Let's go to MEM2, 7. And let's do the normal video RAM test. And so an addendum to this, I asked in my Part 5 video, the sparkly effect that is on these, that is reminiscent of the sparklies you see in the 1986 revision of the Gimme chip on the Color Computer 3, is normal. So that's not anything to be concerned of. Thank you for that information. And the reason here is I kind of figured it was probably okay, mainly because the Model 12 and 16 also do it. So, good to go. Okay, now this did work. Test passed. Press brake to go back. I want to do, we don't have graphics. Oh, let's do the shadow ROM checksum, or the, yeah, shadow ROM checksum. AD85, that is the correct checksum. Alright, because we saw that when I was looking at the README. Perfect. So, this is also a great test of the FDIV ROM that I now have in here. Checkerboard test. And we'll just dip to white and come back when we're done. And the checkerboard test passed. Okay. I keep hitting spacebar for some dumb reason. Alright, we're going to do coincidence first, only because I want to save the other test. And we'll do the bank select test too, because the modified address test is very long. So I'd just like to let that go. And we passed. One other note I want to make, the PIO tests, because I didn't have the loopback cable, failed in exactly the way they should, which I kind of wondered as much when the Model 12 also did the same thing. I figured I was missing something, and I was. So, okay, bank select test passed. Alright, now we're going to move on to the modified address RAM test. This one is going to take quite a while, so we'll see you on the flip side. Fortunately for you people, you don't have to watch this. I'll just be here with the whiskey. Alright, test passed. No bad RAM found, so that's good. Okay, I think I have everything I want here. I'm going to reboot. The only other thing we're going to do here is I'm going to do the CTC and interrupt tests. And assuming those all come out okay, I'm going to assume that everything else is just fine. System 8. Either way, C, CTC. Do them all. All tests passed. Excellent. Okay, and the interrupt test. Actually, I think I can do the DMA test. Okay, that's expected. DMA test, though. Looking good. Alright, so the system is in pretty good shape. I think we're certainly no worse for the wear. Having taken this apart and screwed with all the socketed chips, so that's good. I didn't make it worse. The next step is going to be the power supply. We're going to have to load it up and check the voltages on the various lines here. Alright, so the tripod here for the camera. We're set up. I got the meter here. What we're looking for, I've printed out some of the service manual. Now, this is going to be a little different than the service manual procedures because I don't have an isolation transformer. And the load on the system is going to be the load that I'm using, so rather than load generated manually. But I basically have 5 volts plus 12 volts plus 24 volts and minus 12 volts. And I also have to check the input voltage. And the idea is, on some of these, I should be able to measure on the disk connector, because that's all DC. And then I also, if I'm missing any, I think I will be, I'm going to check on here. If there's any missing beyond that, I can go straight to the power supply. So that's where we're going. If any of these are wrong, we'll follow up with a manual to figure out how to get them adjusted, but those are the voltages I'm looking for. Okay, to measure the input voltage, I actually have the AC input on this side of the power supply. And I'm going to make sure I'm very careful with these probes. And actually we're a little lower, 117.7, 117.8. So that's good. Very careful. The machine is on, so I have to be very careful not to dangle the probes and anything. Okay. Alright, on DC, I'm going to attach an alligator clip here. I'm actually going to use the ground fin right here on the back of the card cage. And I'm going to attach here, and then we're going to drop this way out of the way so there's no chance of contacting it. Alright, and then here on the plug, I see we've got a bunch of connections here. We've got the green is ground, so we're not going to bother with those. This first one I'm going to do is this yellow one on the top. And we have 24.0. Excellent. Okay, next up is going to be red. 4.95. Right on there. I'll have to look and see if that's close enough or not. Meter variation right on 5. I'm probably going to call it okay. Probably not low enough to cause problems with LSDOS anyway. And here we have, fix my probe here, minus 12.2. Not bad. It's 0.2 over, but again, variations for meter, I'm not sure if that's going to be too far, so we'll look and see if the service manual gets. So the one that I did not see was plus 12. We need to make sure that plus 12 is there. And I see an orange wire here on the expansion bus connector, so I'm going to probe it. And there it is. Now that one's a little high, 12.8, so that might be a little too high. I might have to dial that back. So that's where we are with the voltages. Hopefully everything else, I think everything else is in spec. The 12.8 could be a bit of an issue, so we're going to want to check that out. And by check it out, I mean here it is. So 4.9 to 5.1 on the 5 volt rail, so we are good there. 11.4 to 12.6 on the plus 12 rail, so we're over there. Okay. there's actually another 12 volt rail, so we're going to check both, make sure I find both. 21 to 26 volts on the 24 volt rail, that was dead on. Minus 12 should be minus 11 to minus 12.6, and that was 12.2 or 3. So that's on dead on. So the only one that's out of spec is the 1 plus 12 volt rail. Alright, now it's time to check the waveform of the Q7 transistor collector. So Q7 is this guy right here with the heatsink. And so what I'm going to do is grab the sheet here. So this is from the service manual. This is what the waveform should look like. That's the one on the left there. The one on the right, the base, we're not going to be able to check, because to be able to get to that pin, I have to take the power supply out. And I prefer not to do that. I don't really like... This is easy enough to work on. I've got a pretty good chance of not shocking myself. Before the circuit is energized, I've removed the clip tip from my scope. Not just the tip. From my probe, I should say. And I'm going to attach it to the chassis here for ground. And then what I'm going to do here, and now that this is connected, and even though this is not on, it's been energized recently, so I'm not going to let this float, I'm just going to hold on to it. I'm going to touch it to the top of this, which nothing is going to happen right now because it's off. So I'm going to turn it on, touch the top of this and hold it, set up the scope, stop it, and then we can adjust the display as needed. So on goes the machine. Alright, here we go. I don't know why I'm waiting for the machine to boot, I'm an idiot. Alright, I'm just going to hit the auto setup just to see what this does, but I think it's going to be pretty close. Okay, we're going to stop that. I'm going to carefully remove the probe and disconnect it. Okay, and now, let's see what we've got. Okay, there's our waveform. And this is what our waveform should look like on the left here. So we've got a bit of a trailing, and then we shoot up, and then we kind of come down and we ripple, and we have a little secondary one. This is a hand-drawn one. It's close. But I think it's pretty much close enough, and then it kind of levels out, and then if I zoom this out a bit, you can see we repeat the thing again and again and again. So overall, I think that's close enough. So it's the next day, and it's been pretty eventful. Through conversations with folks in the Discord, thank you again to all of you who have been helping me out and taking the time. Really appreciate it. I found out that this is not the only Model 16B that won't run LSDOS. And the exact reasons for that we don't know. There's been a couple of ideas put forth, but there is these machines. I made the assertion earlier that these machines, the 12 and the 16, were exactly the same. And while I guess that two manufactured at the exact same time are probably pretty similar, and they use the same base components, there may be differences between the two. And certainly this 12 and the 16B, I don't know when they were both manufactured. I'd have to pull the cover off the other one to find out. But it's entirely possible that the timings changed minutely, but enough to affect LSDOS. So, LSDOS on these machines is a novelty. Yay, Model 4 software runs, except most of it doesn't. And I just really did it because I was trying out other operating systems and thought it was a good way to kind of check out the machine. But it's led me down a bit of a rabbit hole. And knowing what I know now about this machine, the possible differences with the Model 12, and the fact that LSDOS just ain't worth it, I'm going to move on to XENIX. And what we're going to do, since the 68,000 cards are in there, I haven't tested them yet, I am just going to try to boot XENIX 135 and see if it at least starts up. If XENIX starts and doesn't complain about floppy disk access or anything else like that, then I'm going to call this thing good. If it doesn't start, obviously that's going to lead us right into Part 7 anyway with the Diagnostics. So, that's the next step. I'm going to get this power supply back together once the machine's turned off, of course, and we're going to try and boot XENIX 135. Alright, all reassembled and ready to go here. I put the whole thing back together. Anything that we're going to run into now is going to be a result of, board accessible stuff, card cage stuff. So I'm not going to have to worry about doing anything else in the machine for the most part. One note, if you've been paying close attention, the insert diskette prompt is now mixed case. That's because I upgraded the ROM, and the new ROM has mixed case. Neat. So I haven't done any of the diagnostics. That's going to be Part 7 for the 68,000 boards, but I figured we'll at least see if it can see it. I'm going to try and boot the XENIX 135 install diskette. And at the very least, it will tell me whether or not it sees the 68K, because there's a bug check, no 68K message if it doesn't see it. And maybe it'll even try to start up, but we'll see how that goes. I'm not terribly confident that this is going to work. I haven't done anything with these, but we'll see what happens. Okay, get that far. Yep, memory verifier. Okay. So the next step is going to be the diagnostics. So we're going to run the 68,000 diagnostics on these boards. That will probably tell me where the memory issue is. The 68K board itself is multi-layer, so if anything that's not socketed needs work, that's not something I'm going to be able to do. I'll have to see if someone else in the community would do it for a fee. Hopefully we're just talking about socketed stuff here, and I can deal with it. So that's going to wrap up part 6. The system is a functioning Z80 system. TRSDOS is its own little enigma, but this is not the only 16B that it doesn't work on, so bleh. I'm going to move on to part 7, the final part in the series, which will be getting the 68K boards up and running. And then once that's done, the restoration series is over, and we'll probably follow up with a video of installing XENIX on here. There are pre-made images, but I might just try to install it anyway, just to relive the joy of installing XENIX from 1983. So, thank you for watching, and we'll see you next time.